Okay, my slide up.
Thanks.
Okay, hello everybody. My name is Dr. Sasha Nikolic. I'm from the University of Wollongong, and I have targeted this presentation to help you understand what are the current challenges with AI, or generative AI in particular, within education, and what are some of the opportunities available for innovators to come in and try and provide some much needed solutions. Okay, so from early 2023, once we found out that ChatGPT 3.5 was able to pass a whole range of different assessment tasks, the educational community went a little bit into a panic mode. And what was decided between the community is that we've got to work collaboratively together. We've got to come up with a whole new range of ethical, um, ethical frameworks to work out how do we use this within education. We need to work out what are the risks, what are the opportunities, and so forth. One thing that we have realized is that we can't ignore AI or generative AI. It is being used progressively more across people in the community. This is going to be something that will eventually become more than logging into ChatGPT or Copilot or Gemini. All our devices, applications, in some way eventually will be integrated with some form of AI, generative AI platform. One thing that we have to realize as a community is that generative AI is currently the least capable that it will ever be. While ChatGPT 3.5, put AI in the mouths of the community, everyone started talking about it. It wasn't actually that good, but it has been progressing very rapidly. And that's what some of the discussion today will be about. One thing that we need to be aware of is that we're currently not at the stage of artificial general intelligence. Generative AI is more or less a predicting tool where it's been trained on a massive database, and in essence it predicts what it is that you as a user wants from it. So at the moment it cannot replace you, but what it can do is it can assist you. And the way that it's been termed in the community, and the term that I like to use, is called co-intelligence. So it's about applying your intelligence together with that of the AI to become something very useful. And the way that we like to talk about it is in terms of having a personal assistant. A personal assistant that you can get for around about 30 Australian dollars a month, and it can be an almost expert in anything that you need it to be. The biggest question is can you trust them? So the way that you need to think about it is, if you've got a team of students or a team of colleagues, how much can you trust them to do a particular task? Are you required, if you're the leader, to check over and make sure that anything that they provide you is correct and accurate? And usually if you're a leader or a manager of any team, you need to do that. And that's how co-intelligence works. Now, the most important skill in the education sector is going to be evaluative judgment. That is the ability for individuals to be able to look at the output and determine how accurate, current, reliable, and so forth that information being presented to you is. And that is probably one of the greatest opportunities available at the moment, is to work out new methods of how can we teach and ensure individuals develop evaluative judgment. And Margaret Bierman has done quite a lot of work in this area if you want to read up a little bit more about it. Within education, we're in a situation where we need to balance the risk and rewards. If you know what you were doing, the integration of generative AI is extremely powerful. It can make you work extremely productively. However, if you don't know what you're doing, it is a very dangerous tool. This is because it can hallucinate, provide you wrong information, and if you haven't got that high level knowledge, then you are at risk of using information that will be of detriment to whatever you're trying to do. And this also occurs into how you are applying learning. So a common um, procedure that some students might want to do is they go into their class, they get tutorial questions or assignment questions, and all they do is they simply go in and they upload it and they get the answer. And what students will do is they'll read through the answer and go, oh yeah, that makes sense. I can follow that. I can do that myself. However, just by following such a procedure only puts this learning process into short-term memory. What we want is we want such learning to go into our long-term memory. So when it comes down the track and we have to answer such a question in an exam, we will be able to use our long-term memory to remember how to do it. Now, beyond the exam, the way that long-term memory works is very similar to generative AI, actually. All our different experiences that go into long-term memory get filed into our brain, and when we're faced with a certain problem or a certain situation, all that knowledge becomes tacit knowledge, and our brain works as some sort of predictor, and it presents information to us or ideas that will be able to solve that problem. So in order to be very good at solving problems, we need to make sure that we have lots of tacit knowledge stored in our long-term memory that it can access. And the way that that occurs most productively is through active participation. And there's no way around it, but learning needs to be challenging for the learning experience to get into long-term memory. The greatest hurdle that we have within education is trust. Humans can't trust other humans. Humans can't trust AI. AI can't trust humans. And as educators, we fear that students will underestimate the impact it will have on their learning. For example, what I was just discussing on the last slide, where students will simply want to upload questions, read the answers, and think that they're learning from that experience. And we know that's not going to happen. Then we have factors such as cheating and so forth that we're worried about. So when generative AI started to make lots of noise, I formed a multidisciplinary team from a whole range of different institutions. And what we did is we looked at the assessments across 10 different subjects, and we plugged them into ChatGPT 3.5 to see what was the minimum effort required to get it to pass our assessment tasks. Beyond that, that work was so successful that we led to building the A squared I, E squared C community, where we have now got over 50 researchers from 14 Australian universities working together on 6 different clusters to develop our understanding of how to integrate AI into engineering education and to determine integration opportunities. So our first study in 2003 showed that ChatGPT was slightly better than engineering education. It was a clear winner when it came to online quiz, numerical questions, programming, and reflection and critical thinking activities. Visual, project-based, and research type assessments were still better than what ChatGPT could do, and oral and written experimentation were a tie. Now, when it comes to cheating, some people think that you can always stop cheating, but the problem with that is that if you think that's the case, you just haven't got a good enough imagination. And this is a really good, exciting way of a student using their absolute creativity to try and work out how they can cheat in an exam. And that leads us to assessment security. What can we do for whatever assessment task that we are giving students to ensure that we can secure it as much as possible? In Q1 2024, we updated our assessment task. We looked at ChatGPT 4, we looked at Copilot, we looked at Gemini, and we also looked at the Wolfram GPT and SciSpace GPT. And what we found was that online quizzes improved by 24%, numerical by 41%, written research, which was academically secure before, as it now became a risk. So the strength of ChatGPT 4 has increased substantially compared to 3.5. We have created a paper in AJEE which looks at the short-term security options, long-term security options, and opportunities available. Key, I guess, for the next genius group is to look at what innovations can be applied to take advantage of these different opportunities, and I'll be covering some of these in this presentation. So how easy is it to use generative AI in the classroom? And this is probably one of the best examples. What we see here is that you might want to be running a quiz in your lecture. All the student needs to do is take a screen grab and get the answer that they need and pretty easily pass different assessment tasks. I've shown this to students so that they know that we know what is available out there. So if we look at online quiz performance, when it came to 3.5, it did a reasonable job, pretty much just passing. However, in our updated study, you can see that its ability to pass different assessment tasks has improved substantially, and different technologies have different strengths and weaknesses in which assessment, which technology is the best, as you can see here. In terms of short-term security, you can still beat the generative AI if you're using complex figures and tables. It's still stuck on being able to interpret the more simpler things. The more complex you get, the harder it is for it to provide the answer. But we're getting to the state that eventually image recognition will be good enough that if we want to be able to assess with confidence that students have capability using an online quiz format, if it's high stakes, it has to be supervised. Now that can be in a lab where you know what software students have access to. Anything that is not supervised, then the quiz must assume that GenAI can be used as a part of the solving of the questions to get to the answers. Okay, you can't separate that. You have to just assume they're going to have access. So in order to have a look at the capability of image recognition, this is an example of a simple electronic circuit where we want to find the current. And all we did is we uploaded this image and just asked ChatGPT-4 to solve it for us. And what we found out is ChatGPT-4 was able to do that accurately. We then looked at a slightly more difficult circuit, and unfortunately it got that wrong. We looked at something within mechanical engineering to determine the shape factor, and again, it struggled to do that. But just before our paper was released, ChatGPT 4.0 came out, and what we found is, yes, it can still do our simple circuit. It now could do the more complex circuit, but it still struggled with our shape factor. So what we did is we had a look at why. Why was it getting it wrong? So if we had a look at ChatGPT 4, it was reading the dimensions of the shape wrongly, and from there more errors were creeping in. When we looked at ChatGPT 4.0, it was actually being able to now read the shape and the dimensions correctly. It was here when it got to the calculations that the errors started to creep in. And this is something that we've seen through our investigations, that when it comes to mechanical engineering style topics, that it has not been trained as good as it has for electrical engineering style topics. But that is something that as training improves, the accuracy will also improve. But we can see that the image recognition is getting substantially better. There are some ways that we can beat that, and we can have a look at the approaches that the different technologies have used in terms of the ethics of analyzing humans. So if you're using Gemini, if you were to place a picture of a person together with a question, it can't analyze the picture because it can't process any images that contains people. If we have a look at both Copilot and ChatGPT, they both can answer the question. The reason is for Copilot, Copilot blurs the face, and as long as the face is in the part of solving the question, it is able to do it. But when it comes to ChatGPT, there are no rules in terms of people, and it can just analyze anything that you give to it. Okay. So the opportunity for the entrepreneurs out there is, how can you create a new system that can protect quizzes from such threats? And quizzes have become famous in terms of education because it is quick, easy, provides fast feedback for the educators and for the students. But it's simply not feasible anymore. And any entrepreneur out there is really, it's the challenges out there. What can we do with the threats that are currently out there that I've just shown you? How can we do this in a new way that generative AI will not be a vulnerability? Next, we have the numerical questions. These are the assignment exams. These are where you have multiple lines of questions. So you're getting marks for both working and for the final answer. So when we did our original study, pretty much everything that ChatGPT 3.5 did, the final answer was wrong, but it got lots of working correct. So students were able to pass most assessments because there was enough marks in the working before it started to make the errors. In our updated study, what we found is that in many cases it was getting the working right and it was getting the solution right as well. The biggest differentiator came on the topic area. Some topics it is excellent at, some topics it's not. Again, that comes down to the level of training some topics have received compared to different ones. Generally speaking, ChatGPT is best when it comes to providing you a detailed understanding of the process of solving the question. Wolfram is best when it comes to providing the final solution. Again, same sort of thing with short-term and long-term options. Using figures and tables can help slow down ChatGPT, but with no surprise, we're getting exactly the same long-term options. It's either high stakes examination, you make it a supervised with no generative AI integration, or if it's an unsupervised assessment, you need to make sure that whatever question you're asking assumes that generative AI must be a part of the, the question. It's a tool needed to answer the question. Now, as a result of this, the University of Sydney is actually applying a two-lane policy from 2025, which implements this exactly as I've mentioned. So you've got your high stakes supervised and high stakes unsupervised, where anything unsupervised must assume that generative AI comes into the equation. Now we've been doing some analysis of its reliability. So here you can see a traffic light system where 0 is 100% inaccurate. 4, which is the dark green, is completely accurate. So we looked at 4, 4.0, Wolfram, and Tudor-Me, and you can see how for digital signal processing, it's pretty well accurate. When it comes to fluid mechanics, some topics it's just terrible on, some it's good at. Same sort of thing with mathematics, where there's some strengths and some weaknesses, especially across the different platforms. And all this came together because we've been looking at using generative AI as a tutor. So the idea behind the tutor is that the student provides in one prompt, and it will provide the personal learning journey where it will provide theory, it will provide questions, the students will answer the questions, and depending on whether the student gets it right or wrong, it will adapt the information and future questions based on that personalized learning. The greatest limitation that we have found from our research at the moment is accuracy, as per the previous slide. And the other issue is communication. So when it comes to engineering content, you're writing equations. It is extremely difficult to write multiple lines in a chatbot of mathematical equations. So for the innovators out there looking for a solution, it becomes, how do we better communicate with generative AI? At the moment, we've got voice, and one solution would be to, speak out what the equation response is, but still that's not good enough. So if any innovators want to be out there.
喂，
你稍等，不好意思，我 mute 一下。Sorry.
Okay. There is your opportunity. Next comes to experiment-based assessment tasks. And for all laboratory type work, you have a component or a possible pass. The reason is because pretty much all assessments in laboratories are undertaken via a report. And as we know, anything that's text-based, generative AI, that's their strength point. So what we need to do is we need to work out ways of beating that. In terms of short term, moving away from reports is important. Don't repeat the experiment and so forth. But longer term, we have to realize that experimentation and any active-based learning, there's more than just cognitive learning that universities have been concentrating on for so long. We need to consider the psychomotor domain, and we need to consider the affective domain. And these two are important because at the moment, these are the areas that generative AI can't get involved with. These are the strengths that humans have over the technology. All right. So this allows us an opportunity to assess things that generative AI can't do. And for a little bit more insights you can have a look at this paper. Now, what I want to show you here is another heat map. Now, you can't read this, and that's on purpose, but key to the image is above here are a whole range of different assessment types that are used to assess cognitive learning objectives. And these are the different learning objectives associated with the cognitive domain. And when you see something green, that means that as academics are very confident that these assessment types are capable of evaluating the capability of students for these different learning objectives. So the more green, the better. So you can see the whole range of different assessments are capable of measuring a whole range of different learning objectives. However, when we look at psychomotor learning objectives and affective learning objectives, you see the green pretty much all disappears. We have very low confidence that these different assessment tasks are actually able to assess these different objectives. And this creates an opportunity. The reason we have an opportunity is because the different learning outcomes, different assessment types have different strengths and weaknesses regarding the learning outcomes they are capable of assessing. And each assessment types has a different impact of security. So for example, lab reports are a very effective tool for assessing learning when it comes to cost, because you can sort of like see, can the student demonstrate that they've completed the results, able to write it up. However, while it's very easy to mark, it is very easy to cheat with, and that creates a huge problem. So the opportunity for the innovators out there is, how can we better evaluate those psychomotor and affective skills? Now, before COVID, before generative AI became popular, I've had some students, look at some different ways of assessing their capability. One way was a student created a autonomous practical lab exam. So the student would be able to set up a circuit on what we call a wishmaker, which is like an advanced breadboard. And at the end, the device itself would be able to provide the mark of how well the student built the circuit. And that is an efficient way of getting feedback to the student and recording the marks and being able to test whether the student was able to do the psychomotor skills required to build. Another example that we had is a student working in a virtual environment, completing things. The activity opportunity is, how can you perform psychomotor and affective learning activities and be able to measure them using that technology. Another option for innovators would be to use a camera to watch students do things and be able to measure and record their capability. So there are a lot of opportunities in this learning by doing space. When it comes to written and reflective and critical thinking, it was very strong before, and that continues now. The only area that it failed was when it came to a video based, because at the moment the technologies tested weren't able to upload and provide a reflection on a video. As some examples, you can see that if you put in the framework of reflection required, it is able to complete it very easily. And this is an example of Copilot. Copilot even gives you a whole range of different suggestions to help you improve it. Even if your prompt is terrible and you don't know what framework to use, here's an example of Gemini, where it provides you the template where you just need to change to be able to get marks good enough to get you to a pass. Here we have an assessment where the student has been asked to apply critical thinking to consider the limitations of this ChatGPT output. Now I've heard of a lot of academics thinking that this is okay. The problem with that is that you can simply write a prompt to do the critical analysis. So if it's an unsupervised assessment, you can't even guarantee that the student is doing this activity. So the opportunity for the innovators out there is, how can you create a system to protect such assessments from such threats? The final one, that assessment type that I'll talk about, is research-based. And as I mentioned before, it was quite secure in 3.5, mainly because ChatGPT hallucinated so much, but especially if you use plugins such as SciSpace, which allow you to interact with a database of real literature. It is very easy, and there are a whole range of different YouTube videos that take you step by step through the process. Now, when it comes to the application of AI in education, the biggest problem is that everybody seems to be too busy. There are so many different ways that technology can improve productivity, but people just don't have the time to learn how to use generative AI, and they haven't got the time to explore. And this is again an opportunity for the innovators out there of what are the solutions out there to help people upskill in a very rapid way. One thing that we think co-intelligence is best at is we came together within the A squared I, A squared C group, and we have created the project work Artificial Intelligence Integration Framework. So this framework provides a rundown of all the different opportunities that you can use AI within project work. So this is for project work at the university level and also at the industry level. And the opportunity for the innovators becomes is what plugins can be designed to integrate all these different components to make project work faster. This can be at the education level or it can be out in industry. How can you use it at work? One way of doing it is to write quickly, write your ideas down without worrying about grammar and all that sort of thing. So you work at speed, you plug it into your generative AI, it refines. And right at the beginning, I told you that the most important future-facing skill is evaluative judgment. And that's because even though the technology provides you with the text, you need to use your evaluative judgment to improve what was given to you, to work out what was not suitable, what needs some correction, etc., and adjust it exactly to your needs. Another way of using it is to check for alternate perspectives. So, for example, if I am going to be presenting something in a presentation such as this one here, I might list my own thoughts and I might ask, all right, what counter arguments with what I'm going to say could people come at me with? This allows you to check what you may not know, and your evaluative judgment becomes your ability to assess the counter arguments that it's given you and think about, all right, which ones should I include in my presentations? Which ones should I be prepared to argue about if I get that from a question from an audience or so forth. All right. The most obvious one, and used quite a lot, is for brainstorming. So you can put in prompts to work out, all right, give me some ideas. Evaluative judgment is required to work out which ideas are suitable and which ones aren't, and then you take your action. Another one is troubleshooting, and this is where a lot of people in industry are currently using generative AI. Tech support especially, is that, as a first call or maybe a second call, is whenever they run into a problem, they'll put that problem into the generative AI. They'll get a whole range of different possible solutions. They use their evaluative judgment to come up with a whole range of different solutions, and then it's time to take action. At the end of the day, a lot of it's going to come to efficiency, where we're going to try and work out how do we eliminate all the mundane tasks. So for example, we might have a report. We want that turned into a presentation so we can upload the report. It'll create an automatic presentation for you. What you then need to do is apply your evaluative judgment to make sure that you refine it to meet your needs. And at the end of the day, there are many, many different ways of improving your productivity beyond the examples that I've provided. If you're interested in the key points of the study, I highly recommend that you read our study. It's open access, which means it's free, and it's available at the Australasian Journal of Engineering Education. And that comes to the end. The question becomes, do we fear it, embrace it, or try and ignore it? I think the only answer is that we need to embrace it. And are there any innovative opportunities available that have created an interest from you based on this presentation? And I think we can stop sharing there and have a good discussion.
Yes, thanks so much, Professor Sasha. I think I've been learning a lot during the last 30 minutes. So one thing I come very straightforward to my mind is like since the ChatGPT and GenAI things coming in, is there like the academic standards becoming more strict and like getting high level? So from that end, if the students or practitioners they're not using the Gen AI, they probably would be easier to getting out of like the general scope for the yeah. So for example, if people are drafting a paper or maybe doing an assignment without any Gen AI support, probably the score will be getting worse compared with like old days. Is that like from the educators' point of view, we will also consider about it to kind of change the standard to make it more suitable for all the participants, or we just follow like we just assume that Gen AI is already there, so everyone should utilize Gen AI to do something, then the standard will keeping getting higher and restricted all the time.
We're in a huge transitionary period. Okay, so a lot of academics have no idea what to do. They've been keeping the same. But what we've been noticing across Australia is that more and more students are using generative AI for their assessment tasks. A lot more have been getting caught, and that's problematic. In the long term, we have no choice but to adapt our assessments to change them as per the two-lane policy being implemented at the University of Sydney. I don't see any other possibility. The reason is that detection, it's not something that we can do reliably, and some students will, some students won't. We have to level the playing field, and that two-lane is the only option. And when integration comes into play, that is the opportunity to lift the bar. So in my subjects, I've been allowing that integration, but I have been openly telling them that the bar is being lifted. I expect more from you now.
Mm, mm, mm. So the maybe for some people who's not like a tech savvy and they probably just try to avoid using the many tools, uh, is that they have to change or like they probably have another approach to improve themselves?
Yeah. Well, I'm in the field of engineering. Engineers need to work with technology. Digital literacy is something that's central to the curriculum. And ChatGPT or Gemini or Copilot, whichever technology that the university wants to implement, is just another digital literacy skill that students will need to develop. You can't be an engineer and not be comfortable using technology. It could be something else for different disciplines, but people in engineering, information technology, etc., there's no excuse.
Mm, mm, mm. Yeah, got it. Thanks. Yeah, I probably have some more questions, but I will leave the question to the audience first. Or if no, I will continue with my second. Raymond, yeah.
Yeah. Hi, Sasha. Thank you very much for presented this. For your presentation. So I'm curious about like the assessment of the different ChatGPT method, like for the underperformance. I mean the not passed one or not good performs the testing. Like for ChatGPT, is there some common pattern for this test case? Like what kind of the test case will make ChatGPT like not perform well?
Okay.
And Yeah.
So it really comes down to areas of training. What we have seen is that for some topics, it has been trained really well, and that is why it's giving you good answers. And for some topics, it's simply obvious. We don't know how it's been trained, but it's just obvious that for some topics it hasn't been trained well. And that is why
Yeah.
you get huge difference from one section to the next. Now, if you want on your own to improve it, so if say you're teaching mechanical engineering and you want to improve it yourself, what ChatGPT has, it has the GPTs, which is like, for example, Wolfram, whatever. And what you can do is you can create your own ChatGPT where you can train it on the content that it's not trained on well. And you can get your students to, for example, use that, where it will use the engine of ChatGPT, but it will look at your materials when it's solving the equations, and it can be much better at solving those type of questions.
Yeah. Okay.
Okay.
Yeah, because yeah. Please continue. Yeah. Thank you.
Yeah. So that's what I was saying is that's the workaround at the moment.
Yeah. Yeah, because I show like you like from in the example you showed us, like there are some like electrical circuit and then testing, and it calculates well for some question and doesn't work well. So, but for the real electrical engineer, like when they design the system and like the calculation is important for the design, to populate the blueprint. But when they study as a student, and then they some students like they can get the result from the ChatGPT and pass the exam, right?
Yeah.
But in the real world, it couldn't allow the failure if they make some mistake, right?
Yeah.
And yeah.
So when it comes to image recognition, we need to remember that image recognition's only been available for about 1 year, right? So 1 year ago, it wasn't available. Now it's there, and it's already progressing pretty quickly. It's getting better. And we're seeing that it's able to understand the image. That's getting better and better and better. And
Yeah.
depending on the topic area is depending on how good it does calculations. Just remember that generative AI is not a calculator. It's done in predictive format anyway. So it requires that training to get there. And the way that it's going to have to be used in the workforce is, you know, if it's going to be used, that evaluative judgment needs to be that key skill. That's why I keep talking about that being the most important future-facing skill that any graduating student is going to need. Because one way or the other, we're going to need to use it to make us work faster, but we need to have the judgment whether what it's providing us is accurate and reliable. You know, we can use it to design a bridge, but if the bridge collapses because our formula was wrong, our results were wrong on our design parameters, we can't blame ChatGPT for that failure. The failure comes down to the human who checked off that this is correct. So we need that judgment that whatever we're working with is correct. The same sort of thing happens now with simulations. A lot of design is done via different software packages. At the end of the day, the human has to look at that results and be able to use their judgment to say, yes, this is correct, or no, there's an error here, double check it.
Okay.